So now let's look at lesson 13C. In the next preview assignment and in the next class, you'll need to be familiar with samples and populations, as well as you need to know how to calculate absolute error. So we're going to start with a sample and population. And these are words you definitely need to add to your vocabulary list, however you're documenting it. And so let's start with a representative sample. A representative sample is, this is where we start writing it down, a subset of a statistical population that accurately reflects the members of the entire population. I would write all of that down because it does need to say information like it's a subset of this population that we're going to be looking at, and that it accurately reflects the members of the entire population. It's got to really be a representative sample. A representative sample should also be an unbiased indication of what the population is like and can be used to, here's this word again, draw inferences about the total population. So that thing is packed full of information. Take another look at it, think on it, look at what is going on in that definition for representative sample. Then we're going to move on to question 1. But before we do, this is a great time for you to go ahead and hit pause and at least answer question 1. You may want to keep on going to question 2 and maybe stop there, and then we'll pick back up at the absolute error. But do hit pause, answer question 1, and I'll see you back in just a second. So question 1 is asking us to determine which of the following best, and boy, that's a huge word, because representative is going to need to be the best sample of the adult population in the United States. So let's hone in on just a few words. It's the adult population in the United States. So when we look at this question's part A, so if we do a collection of 100 randomly chosen adults over the age of 72, will that capture a good representation of all the adults? No, that won't get, if you consider 18 adult, then that won't get the 18 to 71 group. So cross out A. Go to B. A collection of 100 randomly chosen individuals who voted for the current president. Is that going to be a best representation of all the adult population in the United States? Well, first off, it gets voters, and then it gets the ones who voted for the current president. No, that is not a good representation. Let's keep looking. A collection of 100 randomly chosen adults from the United States. Period. End of story. Random adults. This one sounds really good, but let's keep looking. A collection of 100 randomly chosen, oh, I like this one. 100 randomly chosen math instructors from universities around the country. No, because there are more occupations in the world than math instructors, and there are even some of us who are not at a university, we're at a community college. Anyway, we need to wipe that one out because it's not representative of all the adult population in the United States. So our answer is C, and let's look next at random sample. So break out those flashcards or sticky notes or something. We've got some more words to make a huge note about. So it did mention just a while ago in the representative sample that we would select the adults randomly. So ideally, members of a sample are selected from the appropriate population. We want to get it representative in some random way. And a random sample is a sample that is chosen by random selection. And we're going to talk more about that in our 1332 class, but this is just getting an understanding that there is a thing called a random sample, and that it is a sample that's chosen by random selection. So go ahead and do question 2, and then come back and we'll talk about it together. But hit pause and go ahead and look at question 2. So question 2 is talking about a grocery store. And a grocery store wants to survey their customers to determine if they prefer to purchase bulk items or name brand items. So describe a strategy for obtaining a random sample of those customers. And this is where just think about different surveys or different things that you've participated in. Think about those. You can write down an idea there. They could select every random 30th customer or something along those lines, but they'd even still need to randomly select the number that they pick, whether it's 30 or whatever. One idea is that the computer connected to the checkout counters could randomly select customers for the survey. And is that really random or not random? And we'll talk more about that. How do you know if something's really random? We're never going to get it perfect, but still keep in mind there is a thing called a representative sample and something called a random sample. A few more things you need to know before this next lesson. It's called absolute error and means. So again, break out the flashcards, glossary, or sticky notes, something, because you need to write down absolute error. It says sometimes you have a scenario where the population mean is already known. And I was talking to a student today who just had part of this class yesterday, and we were talking about the population mean already being known. And if we did want to talk to people about the presidential election upcoming in 2 years, can you really talk to every single possible voter who will be voting in that election? And that's impossible. We don't really know the population mean, so we do a sample. But as this paragraph says, sometimes you've got a scenario where the population, you can actually know its mean. And in this situation, if a sample is then selected, the error between, I hope you're writing or underlining, the error between the actual population mean and the sample mean helps to identify outliers. Well, there's another word, outliers. And this error is determined by, let the alarms be going off that you're writing down, it's determined by the absolute value of the difference between the population mean and the sample mean. And if you look right here, they wrote it out in math form. It's a math sentence. The absolute error is, here's absolute value of, take the population mean and subtract the sample mean. This is an example of absolute error, which can be applied to other measures such as standard deviation, and we'll talk more about that in our 1332 class. The calculation is as follows. So take a minute to study on. Absolute error is going to be the absolute value of the population mean minus the sample mean. So now we're going to go on to question 3, which was talking about earlier, and it's going to help us to look at and manipulate and to work with absolute error and means. So looking at question 3, there are parts A, B, and C. At least pause and go work on question 3. And you may want to go ahead and work on questions 3 and 4, and then come back and work on these with me. So looking at question 3, suppose your local grocery store is interested in determining the average single spending transaction of its customers in a given week. The store collects the following data from 12 randomly selected customers that week. So you see the table. We have customer listed 1 through 12. They're anonymous. And then their transaction amount. Notice the things that it asks us to do in A, B, and C, starting with A. A says compute the mean transaction amount using the data from this table and round to the nearest cent. Well, what we're going to need to do is to add up all, oh, not that all, but add these all up. And then we're going to divide by 12. So the sum of all of those receipts turns out to be $627.15. We're going to divide it by 12 to get the average, and that is approximately equal to $52.26 rounded to the nearest cent. I'm not going to change screens just yet. I want to go ahead and read Part B. Part B says, suppose the store was able to determine the real average transaction of the entire population of the customers during a given week. And y'all, talking about big data, you know Amazon's doing this, or Walmart. They know what we're buying. They're predicting what we're going to buy next, and all these things that pop up and say, customers like you also purchased. They are running the numbers steadily. So yeah, it is possible to know certain entire populations. So in Part B, they've got it. And they computed the average to be, and I'm going to change colors on this one. They computed the average to be $54.78. This is the actual population mean. The one that we calculated, this $52.26, is a sample mean, a sample average of that entire population. Remember, it's a subset of the population. Looking at what they're asking on Part B, is the mean of the sample you computed, so looking down here, is this mean, here comes the question, that we computed in Part A greater than, equal to, or less than the population mean? And the population mean is about 54, ours is about 52. So I'm going to have to say that we are less than the population mean. And that would be the answer to Part B. Part C says, okay, then compute the absolute error. Remember the absolute error on the page previous, or the slide previous to this, is we're going to take the absolute value of the population mean minus the sample mean. And once we do the difference and take the absolute value of it, this is called the absolute error between the population mean and the sample mean. So we're going to take the absolute value of the population mean is $54.78, and we're going to subtract, in other words, we're finding the difference between the two. And when I subtract, let me turn the computer calculator on. I have $54.78 minus $52.26, and I'm getting the absolute value of $2.52. And what's the absolute value of a positive number? Well, it is itself. And I'm going to put a dollar sign on there, but since we're doing something different, it probably is better represented as just 2.52, 2 and 52 hundredths. My brain still wants to remember it's money. So on a test, you can put 2.52 and argue with me why you're right, and I'll take it. Go on to question 4. If you haven't already worked it, go ahead and hit pause, work on question 4, and I'll see you back here in just a minute. So finishing up this lesson, question 4 says, given the following sample and population means, and so look at what we've got, a sample mean, a population mean, a sample mean, a population, you get the idea. Compute the absolute error. So I'm going back to where we saw this earlier, and it said absolute error, and you're memorizing this. Absolute error, we're going to take the absolute value of the population mean minus the sample mean, and we're done. It's always good to write down the formula before you start because you could get these backwards. With it being absolute value, you're going to be okay, but it's still a good practice. Like, I'm going to go ahead and write that it's the absolute value, thought I changed colors there. The absolute value of population mean minus the sample mean. I can punch it in my calculator, 6.2 minus 6.5, which is the absolute value of negative 3/10. The absolute value is 3/10. Again, I like seeing the variables, the units. And so the absolute error is 3/10 of a foot. I like the variables, so I may be going back on. You can argue with me on this one. I just think it's a better answer to have the variables. Let's see on the next ones. So now we're moving on to part B. On part B, we already have the formula written on the top of our page. I'm going to go ahead and grab the absolute value. I'm going to start with the population mean. I'm going to subtract the sample mean. And when I do, I get 13. And that absolute value of that is 13. And I just have to go ahead and write. It's the absolute error is not just any old 13, it's $13. Now we're looking at one more. I think we have two more to go. We're taking the population mean and we're subtracting the sample mean because we're finding the absolute error. So grabbing a calculator, I'm doing 78 2/10 minus 80 3/10, and I'm getting negative 2.1, but absolute error, we are to find the absolute value, and that will be 2.1. It's not just any 2.1, it's 2.1 degrees Fahrenheit. And our final absolute error to calculate is on part D. And on part D, the absolute error, we are to take the population mean and subtract the sample mean. We're getting a negative 2, but the absolute value is 2. I'm going to include the units, and we have finished another lesson. So this completes lesson 13C. Go look at the the syllabus calendar and see if you have more assignments that are due this week. If so, let's get busy on those. And if not, make sure you upload all of this week's assignments to D2L by Friday at 11:59 p.m. I'll see you again on a lesson very soon.